Alright, in the previous video we learned how to add and subtract rational expressions with like denominators. This one's a little bit different. This is with unlike denominators. Just remember, whenever you don't have like denominators, you're going to have to find what's called a common denominator. That takes a little bit more time and effort. So let's go ahead and start this problem, and we'll show you guys how to find the common denominator, also known as the least common multiple. Alright, so we're going to put 9x plus 1, and it has a minus for subtracting this other expression, 1 over 5x cubed. So let's take a good look at this denominator. This right here is a binomial, known as 9x plus 1. This right here is a monomial, known as 5x cubed. These are definitely not the same. So, a very easy way to find the least common multiple between two totally different factors right here. These have no common factors at all, is just to multiply them together. So in this particular case, our least common multiple is going to be the product of 9x plus 1 and 5x cubed. Alright, so the product of those will be our least common multiple between those. So that's going to be actually our like denominator, and we don't have to expand it. We can keep it in factored form and it'll be just fine. So right now, what we're going to do is I'm going to give myself a little bit of room. I'm going to write down our common denominator, which happens to be 9x plus 1 and 5x cubed. And we're going to look over here and ask ourselves, what does this denominator not have? Well, this denominator does not have the 5x cubed. So I'm going to multiply the denominator by 5x cubed. Well, whatever I do to the denominator, I've got to do to the numerator. Alright, because technically we're just changing the way it looks. We're not changing the value of this expression. We're just changing the way it looks so it has the same denominator. So we have that right there. Then over here, let's ask ourselves, what does this denominator not have that it needs? Well, it needs the 9x plus 1. So I'm going to put 9x plus 1 right here, and 9x plus 1 right there. Alright, so we're almost done here. All I've got to do now is take this guy right here, and I'm going to distribute him to both terms. So when we distribute it, we get 5 times 7, which is 35. So we'll put 35. X cubed times x is x to the power of 4 using the product property. Alright, and then we have 5 times negative 8. That's going to be negative 40. And then we got to stick the x cubed right along with it. I'm going to make this fraction bar just a little bit further. Alright, we're almost done here. Now what we're going to do is we're going to take this negative 1. Alright, so I'm just going to highlight everything here. Alright, makes it a little faster. I'm going to take this negative 1 right there, and I am going to distribute that to the 9x and the plus 1. So negative 1 times 9x is minus 9x. And negative 1 times a 1 is minus 1. And I'm telling you, we just have our final answer. There's nothing we can factor out to make this more simple. Alright, we got a really long, ugly looking answer that only a mother could love, but we're going to type it in nice and neat and see if we can get this right. If not, we'll find out. Here we go. Let's start with the old fraction bar. Let's start with the denominator, alright? The denominator, let's go and put 9x plus 1 over here. We'll put 5x to the power of 3. And up here in the numerator, look at how long we've got. 35x to the power of 4 minus 35. 35x to the power of 4 minus 40x to the power of 3, or x cubed. Alright, and then what did we finish it off with? We finished it off with a minus 9x. Minus 9x. Minus 1 more. That is an ugly looking answer. There's nothing we can factor out of that sucker that I can see. And if they expected us to, well, that's a lot to expect. Let's see what happens. Woohoo! We got it right. Once again, you could see the old step-by-step solution if you wanted to. Looks like Might be easier just to watch what I do versus watch what they do. But they do a very good job, very nice and neat, a lot prettier text than mine. All right, let's go on to the next question. Ooh, let's take a look at this guy. Ooh, good, we get to add, not to subtract, which should make it a little bit easier. So, what we're going to do is we're going to write it nice and neat. Over 7k plus 2 plus 11 over 3k, just like that. Now, let's take a look at this denominator right there. That denominator is definitely not the same as this denominator, I can tell you that much. Those are totally different. So we're going to find our least common multiple by just finding the product between those. So that's going to be pretty easy. All right, I need to leave a little bit more space to do my magic. Equals my mathemagic. Oh, that's a bad joke. Bad dad joke. So we have 7k plus 2 times 3k right there. And then what we're going to do is we are going to multiply both the numerators and the denominators by what they need so that we can have what's called a common denominator. All right? So let's take a look at this. What does this guy need that it does not have? Ooh, it needs a 3k. So I'm going to put 3k right there and 3k right there. What does this guy need? It needs a 7k plus 2 right here and a 7k plus 2 right there. And then all I'm going to do is do a little distributed property. Got to take that 3k, multiply it to this guy right here. So we got 3 times 8. That gives us a total of 24. And k times k cubed is k to the power of 4. I'm going to put plus. Makes it really easy because there's a plus sign right there. All I got to do is take that positive 11 and multiply it to the 7k. Then take that positive 11 and multiply it to the 2 right there. So we got 11 times 7k. That's a total of 77k. And then 11 times 2 is 22. And, wow, another answer that is simplified. There's nothing we can really do. All right, because the factors of that are 7 and 11, and that's 2 and 11. All right, and that's 2. 2 goes into that, but 2 doesn't go into that, so I can't factor that out. So we're just going to type that in exactly as it appears. There's no common factors between a 24, a 77, and a 22. All right, let's type it in. See what happens. What do I like to do? I like to open up parentheses, type in one of the common. Now, if it said expand, then I'd have to go in and I have to expand everything by using the FOIL method and all that stuff, and the distributed property. But we don't have to worry about that. We can leave it in factored form, which is nice. There we go. There's our first part, 7k plus 2 and 3k. Then here, we've got to type in 24k to the power of 4. Plus 77k plus 22. Let's check it out. Here we go. Alright. I think it's looking pretty good. 24k to the power of 4. Boom. 77k. Boom. 22 by itself, just like it is right there. A nice little constant at the end. Come on, roll the dice. Drum roll, please. Woohoo! Got it right. Awesome. Okay. Moving on. Oh, gotta subtract. Let's do one more subtraction. Alright. Then if we get a really cool problem, we'll keep going. If it's not a cool problem, then we'll just, we might skip it. Alright, here we go. What I gotta do right now. Oh. Alright, here we go. I'm gonna put 2k over 3k minus 7 minus 3 over 8k. Alright, so here's one of our denominators, 3k minus 7. Here's the other denominator, 8k, totally not alike. Alright, well what we're going to do is I'm going to put equals over here. I'm going to make our common denominator. going to put 8k up front, and I'll put 3k minus 7 in the back. You'll notice this time I just decided to put this one over. It doesn't really matter. The product's going to be the same no matter what. And you don't have to distribute it. You can just leave it in factored form for these, unless it says expanded. If it says you need to expand it, then you got to do the distributed property and expand it. And then you would get 24k squared minus 56k. But you don't have to leave. This is called expanded form. But you don't have to expand it to type it in. All right, let's see what we need here. Looks like over here we need a factor, and over here we need a factor to help get the denominator to be a common denominator. So what's this guy missing? He's missing an 8k. I could sure use another 8k. Don't know about you. All right, let's see here. What is this guy missing? 3k minus 7. I'll put it in blue. 3k minus 7 and 3k minus 7. All right. Then all we're going to do is take this 8k and distribute it to the 2k. It's going to get a total of 16k squared. Nice. All right, now let's take a look at this one right here. We're going to take this negative 3. We're going to distribute it to the 3k, and then we're going to distribute them also to that minus 7. So let's take a look at that one. Here we go. So negative 3 times 3k, that's negative 9k. All right, and a negative 3 times a negative 7 is a positive 21. All right. And we are just going to leave it just like that. There's nothing that we can factor that where any common factors are canceled out. So right now we're just going to go ahead and type that in exactly as it appears. All right, I'll start with 8k parentheses 3k minus 7. Go up here to the numerator and we will type in 16k squared. Okay, minus 9k, and then plus 21. Let's make sure we got everything right. 16k squared minus 9k plus 21. 16k squared minus 9k plus 21. 8k, parentheses 3k. I feel pretty good about this. I'm feeling pretty good. Nice. All right. All right, we'll do one more. Oh, this is kind of tricky. It looks like it has a common denominator, but it does not have a common. These are different denominators right here. Look at them being all sneaky. All right, 6z squared over 3z minus 1 plus 2z squared over 3z plus 1. All right. A little room for the magic to happen. Now, this is actually a difference of squares as the common denominator right here. We're going to take a 3z minus 1 and multiply it to a 3z plus 1. Now, if you multiply those together, you get 9z squared, all right, minus 1, okay? But we're going to leave it in factor form. We're not going to expand it into this expanded form. All right. Here we go. Let's highlight once again. We got 3z minus 1, and we've got 3z plus 1, which are two totally different denominators. Okay, here we go. So what does this guy need? He needs 3z plus 1 in the denominator and in the numerator. And this guy needs a 3z minus 1. In the numerator and the denominator. Now, good for us, all we've got to do is take this 6z squared right here and distribute it to that positive 1 and then distribute it to that 3z. So here we go. What is 6z squared times 3z? That's going to be a total of 18z cubed. And then 6z squared times 1 is just plus 6z squared, and we're done with that. Now it says plus, we don't have to really worry about it. There's a 2z squared. We're going to distribute it to that 3z right here, and then we're going to distribute it to that negative 1 right there. So we've got 2z squared times a 3z. Well, that's going to give us a total of 6z cubed. Oh, looks like we got some like terms we got to worry about. Okay, and then we have 2z squared times a negative 1. That's minus 2z squared. All right, so now we have some like terms that we actually have to combine on this one. All right, so let's go ahead and combine our like terms. We've got 18z cubed. All right, we're going to add it to 6z cubed, which is going to give us a total of 24z cubed. Then we're going to take the 6z squared and we're going to take away 2z squared. And when we do that, when we take that away, we're left with, we'll put plus 4z squared. Alright? Because 6z squared minus 2z squared is 4z squared. Alright, so we can actually factor out a 4 and a z squared out of both of those if we wanted to. And that would leave us with a 6z plus a 1. And you'll notice that none of these cancel out any of those. So we can pretty much just leave it as is. We can leave it as 24z cubed plus 4z squared. And I think it'll be faster. I'm just going to, instead of writing it in factor form, I'm just going to write it in expanded form. Right there. And this is how I'm going to write this answer. Let's go ahead and type in our final answer. Alright, we go ahead and start in the bottom, put 9z squared minus 1. It's a nice difference of squares right there. And in the numerator, we're going to type in 24z cubed. Alright, plus 4z squared. Alright, 24z cubed plus 4z squared over 9z squared minus 1. Alright, let's hope we got this one. Man, it'd be a bummer if we did all this work and got the final one wrong, huh? Hate it when that happens. Oh, but we didn't. We got it right. Woohoo! Alright, hope this was helpful. Just remember, when you guys do this, you got to find common denominators. Make sure you use this method when you're trying to find the common denominator. Obviously, if you need some help, you can let me know. Or you can, if you want to do it on your own, you can look at the, quote, step-by-step solution. It's very similar to kind of what we did. You can even use colors to break it down. Alright, you guys have a wonderful day.